So in this video we are going to learn about trigonometric identities and their proofs in a simple manner. See, we all know that we have three trigonometric identities. They are sine square theta plus cos square theta is equal to 1, secant square theta minus tan square theta is equal to 1, and cosecant square theta minus cot square theta is equal to 1. So we have already seen a proof containing these three identities, and today I'll tell you a easier method to remember all these three identities. Now let us draw a right angle triangle. And we know that this is opposite side, and it is adjacent side, and it is hypotenuse side. See, whenever we have a right triangle, the first thing which comes up to our mind is nothing but Pythagoras theorem. And what does Pythagoras theorem says? Sum of squares of the two sides is equal to sum of squares of the hypotenuse. That means opposite square plus adjacent square is equal to hypotenuse square. Opposite square plus adjacent square is equal to hypotenuse square, and this is the Pythagoras theorem. Now from this equation 1, I'll divide equation 1 with hypotenuse on both sides. See, consider equation 1, that means write again opposite square plus adjacent square is equal to hypotenuse square. Now what I am doing is dividing with hypotenuse square on both sides. See here, it will become opposite square by hypotenuse square. So I can write as opposite by hypotenuse square plus adjacent by hypotenuse square is equal to hypotenuse by hypotenuse square. Right? See, the first thing and the only thing which I have done is nothing but dividing the equation with hypotenuse on both sides. So therefore we'll end up with opposite by hypotenuse whole square and adjacent by hypotenuse whole square is equal to hypotenuse by hypotenuse whole square. And we know that, observe the right hand side. So since the both terms, the numerator and denominator, are nothing but hypotenuse, we can cancel them. So we are left with 1. So therefore opposite by hypotenuse whole square plus adjacent by hypotenuse whole square is equal to 1. And we know that opposite by hypotenuse is sine, since because we already know that this formula, this thing, SOHCAHTOA, and from the definitions of sine, cos and tan theta, we know that sine is equal to opposite by hypotenuse. Now I will replace this opposite by hypotenuse with sine theta, so that will become sine square theta, and similarly adjacent by hypotenuse will become cos square theta. So sine square theta plus cos square theta is equal to 1, and that's our first identity. See, I have just proven this identity only with one step from the Pythagoras theorem. So we all know that from the Pythagoras theorem, opposite square plus adjacent square is equal to hypotenuse square, and what I did is dividing that equation with hypotenuse on both sides. Then it will convert into our required form, and we will end up with opposite by hypotenuse whole square plus adjacent by hypotenuse whole square is equal to 1. So since opposite by hypotenuse, that ratio is assumed as sine theta, and adjacent by hypotenuse is known as cos theta. So sine square theta plus cos square theta is equal to 1. That's it. Okay. Now from the same Pythagoras theorem, I'll prove the one more identity. Okay. Yeah. See here. Again, consider equation 2, but let me take one more color for this thing. I'll take sky blue. Yeah. I'll write again the Pythagoras theorem. We know that opposite square plus adjacent square is equal to hypotenuse square. Opposite square plus adjacent square is equal to hypotenuse square. Now I will divide this time with opposite square on both sides. So now this equation will become opposite by opposite whole square plus adjacent by opposite whole square is equal to hypotenuse by opposite whole square. See, what I've done is nothing but I've divided the Pythagoras theorem statement with opposite on both sides, with opposite square on both sides. Now we know that this is Pythagoras theorem. So what does Pythagoras theorem says? Opposite square plus adjacent square is equal to hypotenuse square. And now what I did is I have divided the entire equation with opposite square on both sides. Now it will become opposite square by opposite square plus adjacent by opposite whole square is equal to hypotenuse by opposite whole square. Now opposite by opposite is nothing but 1. So 1 square is 1. So 1 plus adjacent by opposite. Adjacent by opposite can be considered as cot theta, since because we have SOHCAHTOA, we know that tan theta is equal to opposite by adjacent. Tan theta is equal to opposite by adjacent. If it is opposite by adjacent, we will replace with tan theta. Now it is a reciprocal. It is adjacent by opposite. So what we have to do? We have to reciprocate. So the reciprocal of tan is nothing but cot theta. I am repeating once again. See, we know that tan theta is equal to opposite by adjacent. Now what is reciprocal of tan theta? It is cot theta. So then cot theta will become adjacent by opposite. Adjacent by opposite. So now I'll replace this adjacent by opposite with cot theta. So 1 plus cot square theta is equal to, similarly we know that sin theta is equal to opposite by hypotenuse. Sin theta is equal to opposite by hypotenuse. Now reciprocal of sin will become cosecant. That means hypotenuse by opposite will become cosecant square theta. Cosecant square theta. That's it. Now send this cot that side. So 1 is equal to cosecant square theta minus cot square theta. So that's the second identity or third identity, whatever it may be. So cosecant square theta minus cot square theta is equal to 1. Now again from the Pythagoras theorem statement, I will prove the next identity. See here. Again consider equation 1, which is nothing but Pythagoras theorem. What does it says? Opposite square plus adjacent square is equal to hypotenuse square. Now this time I will divide the entire equation with adjacent square on both sides. So now it will become opposite by adjacent square plus adjacent by adjacent square is equal to hypotenuse by adjacent square. See, opposite by adjacent can be assumed as tan theta. We already know that SOHCAHTOA, from SOHCAHTOA, tan theta is equal to opposite by adjacent. So I will replace opposite by adjacent with tan theta. So tan square theta, adjacent cancelled. Here it will become 1. So tan square theta plus 1 is equal to hypotenuse by adjacent. Hypotenuse by adjacent. See, we know that cos theta is equal to adjacent by hypotenuse. Cos theta is equal to adjacent by hypotenuse. And now hypotenuse by adjacent will become reciprocal of cos. That means secant theta. So that's it. Now send this tan that side. It will become secant square theta minus tan square theta is equal to 1. And that's our third identity. And now we just proven all these three identities. Sin square theta plus cos square theta is equal to 1. Secant square minus tan square is equal to 1. Cosecant square theta minus cot square theta is equal to 1. in a very simple manner only by using these trigonometric identities and Pythagoras theorem, only by using this Pythagoras theorem. One second. Yeah. See, I've just taken the right angle triangle, and we know the Pythagoras theorem. From Pythagoras theorem, we have proven these three identities simply by dividing each time, one time with opposite, one time with adjacent, and one time with hypotenuse, and we got all these three identities. That's it. I hope you are very clear with these three identities, and we'll apply these three identities in the next coming videos. And please subscribe and do follow me for regular updates. Thank you.